Hello everyone, welcome to variable separation exercise 15.2 where I'll be doing question number 13, 14 and 15. Now, before that I'd like to talk about the answer of question 11. In the book it's given that x y minus 1 is equals to c, but in my previous video I got the answer x1 minus y equals to c. Now, the difference is, well, one is the negative of the other, but you should check out my video on how constants work to see how this is in fact actually equals to this. Because I will summarize it right here very quickly. If you let this as c1, then you can take negative, which becomes negative x y minus 1 equals to c1, and I'll take the negative on the right hand side. This becomes minus c1, and here negative constant is just another constant which I'll represent as c. So ultimately I'll get x 1 minus 1 is equals to c, which is the answer in the book. Now let's move on to question number 13. So like in the previous video, let's separate the d's first. So tan x dy is equals to minus tan y dx, and put the y's and x's together separately, of course. So with dy we get tan y and equals to minus dx we get tan x, and this tan y, 1 by tan is just cot, so this is cot y, dy is equals to minus cot x dx, and now we can simply integrate both sides. Now what is the integration of cot x dx? So cot x is just cos x by sin x dx. So here let the function be sin x, and the derivative of sin x is cos x, and here simply this becomes the log natural of sin x. So here that means that the integration of cot x is just in fact log natural of sin x. So this is ln sin y. I'll not write the absolute value, the modulus, because it's kind of not required, equals to minus ln sin x plus, we can choose our constant since there is ln on the left hand side, right hand side. I'll choose ln c, or this goes to the right hand side, becomes positive ln sin y equals to ln c, or ln, using the log property, they will be multiplied in one ln. So sin x sin y is equals to ln c, and ln cancels, therefore sin x sin y is equals to c, which is our required answer or solution. Now let's move on to question number 14. So this is simple. We can directly separate the y's and the x's. So we have dy, and we can put this down here, 1 plus cos 2y is equals to, and we can put the dy dx above, so this becomes 1 minus cos 2x. Now we need to recall our multiple angle formula. Now for cos 2 thetas, we have 1 plus cos 2 theta is equals to 2 cos square theta, and for 1 minus cos 2 theta it's 2 sine square theta. So for this it becomes 2 cos square y is equals to dx by 2 sine square x, and here simply this is dy, or sorry, 1 by cos is sec, that means this is in fact sec square y dy by 2 is equals to cosec square x dx by 2, and we can now integrate both sides. And integration of sec square y is just tan y by 2, and for cos x square y x, it is minus cot x by 2, and simply we can choose our constant as c by 2, and here 2 cancels, and therefore cot x plus tan y is equal to c. Oh, sorry. There is a minus sign right here. So in fact, this is minus, that is minus, this is minus, minus is positive. So in fact, we get cot x minus tan y is equals to c. So tan y goes here, c goes there. Let this be c1, and then minus c1, we can write it as c. Sorry for that minor mistake, but this is the required solution. Now, let's move on to our last question for this exercise. Question number 15, which is actually very simple. And in fact, it is very similar to question number 11. So the one I told you at the beginning of this video. So 15 number, x dy by dx plus y is equals to 2. So before we can separate the dy and dx, we need to move this to the right hand side. So this becomes x dy by dx is equals to 2 minus y. Then finally we can put the dx in the above, so it becomes 2 minus y dx. And now we can separate the x's and dy's. So this becomes dy by 2 minus y is equals to dx by x. And now we simply integrate both sides, or here. And I'll tell you just a quick integration trick. If you have a constant minus the variable, then it is equals to the minus log natural of that function right there. And for this is just ln c, and here ln x, and we can choose our constant as ln c. So I'll write it as ln c1, and I'll put this over here. So this becomes ln x plus ln 2 minus y plus ln c1 is equals to 0, or ln x 2 minus y is equals to ln c. That same constants working. So in the end we get x2 minus y is equals to c. Now in the book it's given x y minus 2 is equals to c, but you guys will know how this will come. Just I guess represent it as c2, take negative common from here, put the negative over there. So this becomes x y minus 2 is equals to minus c2. Therefore in the end x y minus 2 is just another constant, let's say c, and that is the required solution in the book. Otherwise this is also fine right here. So this is it for the variable separation exercise, and I'll be starting the homogeneous exercise, which is exercise 15.3, in the later videos, and maybe even some fun math videos in between. So if you learned something new, please like and subscribe. Thank you.